I've done several videos on electron configuration, but I wanted to talk about some electron configurations that are not what we would call ground state. So ground state is your normal electron configuration, like this one for sodium. If you need to know how to write this, you need to go back and look at some of my older videos. But this is the typical electron configuration for sodium: 1s2, 2s2, 2p6, 3s1. Sodium in this case has 11 electrons, which makes it a neutral atom. Now, sometimes you might be asked to write the electron configuration for an ion. It's important to remember that the electrons that are lost or gained to form an ion are lost or gained from or to the valence shell. The valence shell is the outermost shell of electrons. So in sodium's case, it would be that electron there that's in the 3s, because that is the outermost shell in the third. So for sodium ion, we would have 1s2, 2s2, 2p6. So notice here that that electron configuration only has 10 electrons, which we can tell by summing the exponents. And that makes sense, because sodium's charge when it takes its ion is 1 plus. And again, if you have questions about this, check back on some of my other videos. Now, sometimes we are asked to write electron configurations for the excited state. So excited state is when something happens like the electrons get excited by X-rays or light or extra energy that's been provided into the element in some way, for example, by plugging in a light bulb. So when you have the excited state, you have electrons that get extra energy and they jump from their ground state into what we call the excited state, a higher energy level. So that could, for example, look like this: 1s2, 2s2, 2p6, 4s1. This is not a mistake. This is when the electron gets excited, it jumps to a higher level. It will not stay there perpetually. It will eventually relax and come back down, and it will give off that extra energy, often in the form of light, specifically light that we can see sometimes, but we'll talk about that later on. And so then you notice here that this is 11 electrons. So then the question becomes, how do we tell the difference between the excited state and an error? An error would be something like 2s3. That's impossible. Or 2p5, 4s1. That is probably not, that would not be an excited state, because that would be 10 electrons instead of 11. So I just wanted to point out some different things that you might be asked to write with electron configuration.